Hello again, this is Michael Rambaran from HVAC Technologies. On this video module, we're going to focus on pricing up a unit heater, and that was shown in our other video, Unit Heater Schedule Features 2. So the first place we start is at our website, www.hvactny.com. And this is really for our sales reps, so it'll be helpful for you guys to be able to look and see how a unit heater is priced up. So we can go to the website, go to the Manufacturers tab. In the Manufacturers tab, our manufacturer that we work with for unit heaters is Sigma. As you can see, they provide cab heaters, unit heaters, fin tube radiation, and radiant panels. We click on that link, and it brings you to this page. The page has multiple product groups. In the first product group, we have convectors, fin tube, force flow, unit heaters, and wall fin. And the second product group that we deal with, we have linear radiant panels and modular radiant panels. So we're going to log in to the rep login here in order to get to our pricing program. So I'm going to click on that. Okay. My username is mrambaran, and for those who need the password, just please feel free to give us a call and we'll be able to provide that for you. Once we enter the password, we can log into our program. I will notice that the program here has a variety of different areas. I won't go into every single area, but the areas that we use mostly are the create new job and jobs list portion of the program. This program has been very helpful. So what we're going to do is just create a new job. And what are we going to call that job? We'll call this job pricing a unit heater. Okay, and generally you're going to call the job a name. So you're going to call it whatever the name of the job location may be, or the facility. In this case, we'll call it pricing a unit heater, so we can go back to it at some point. All right. So once we create this title and create the job, we just hit that create job tab. This brings you to a cover page for the entire job. You'll notice this page has a variety of different features. It automatically assigns a job number to it. In this case, it's job number 42217, and it on the main portion of the screen we have the quotes portion, which will have our initial quote, which is quote 1. And then on the other side of the page, you have purchase orders and sales orders numbers. This portion of the screen will become active once an order is placed into the factory. So for now, what we want to do is just go into the quotes portion of the program and hit the edit button here on the left-hand side, and you'll notice it is quote 1. So once I hit that edit button, you'll notice a change in the job number here. It's J42217 quote 1, pricing a unit heater. So if there's another part of this job you have to create, we can create quote 2, quote 3, quote 4. In this case, we're pricing up a single unit heater, so we're going to be able to just stick with quote 1. This particular page is the pricing page, where a summary of all the equipment we select will appear once we've saved it. So that it lists a number of items. It'll give us details about the job, and once we win the job, it'll help us to provide submittals for the job. So at this time, we'll just stick with the items because we have to add items to this pricing page. So we'll go over to where we are able to add equipment. So on this side, we can add fin tube radiation, or we can just simply add product in order to get to the unit heater. Once you hit add product, a variety of different options come up. One is convector coils, convectors, element only orders, that's for fin tube element, force flow, which is another term for cabinet unit heaters, and slope top force flow, which is a slope top cabinet unit heater. And you'll see here we have unit heaters, which is where we're going to select our equipment, and then we have wall fin, which is fin tube radiation. Okay, so this particular selection centers around selecting a unit heater, so that's what we're going to do. Hit select. Once you hit select, it'll bring you up to the actual selection tool for the unit heater, and we're going to minimize this, or at least reduce this screen, and then bring up the schedule sheet that we have for the unit heater, and let's take a look at what it is that we have to provide for this particular unit heater. Now this is the same unit heater we used in the features of a schedule, a unit heater schedule. So let's use that again in order to price this up. So you have a flow from one part of pricing up a job to the other. In the Sigma program, as we look at the program, we'll want to assign a packing tag. That means it's the tag that goes on the skid that's going to carry the number of unit heaters we select. This gives the contractor the opportunity to see immediately what's on that skid without having to look at the labels on each individual box. So we'll hit that gray button, and we'll tag this as unit heaters. So when the unit heaters show up at the job site on the skid, it'll have a big tag that calls unit heater, and the contractor will know immediately what's in the crate. Alright, so we'll hit the create button. That'll fill in that field. In this case, we know that the tags are UH1, 2, 3, 4, and 5. So we know we have a quantity of 5 units. So we'll put that in the quantity button that's here. And then what we'll do is set the tags. The tag meaning the tag for each individual unit. So we'll tag these units unit heater 1. And to make life easier, I always hit the make same as first button. So that way it's just easier for me to go back and change that to unit heater 2, unit heater 3, unit heater 4, and unit heater 5. Okay, so once we tag the button, each individual unit, and this is what will appear on the label for each unit. And note that all these units are the same, so we can use this one selection window to select all 5 units. So once we've tagged that, we hit the save button, so all the tags are saved for the particular units we're selecting. Okay. Next, we take a look at what we talked about in the other module is, what are the criteria that are required for this particular unit. And remember, in the other module, I said that the important criteria for unit heaters is really capacity, because the capacity of the unit is really to add heat to a space that's losing heat. In this case, the capacity is 52.3 MBH, or 52,300 British thermal units, BTUs. So we'll go to the capacity portion here, and we'll take a look at what comes closest to that capacity. And in this case, we want to select a unit that slightly exceeds the capacity to see if we can get that performance. And then if we're overperforming, we can always reduce it. Okay, so in this case, we select a size 58 horizontal unit heater. And how do we know it's a horizontal unit heater? From the schedule, it told us it's a horizontal unit heater, so we see that right there. Okay, so the next portion of our selection tools asks for if it's a low temperature output. Now the only choice we always have is the standard temperature output, so we'll select that. The voltage of the unit that we're selecting can be seen on the schedule, and on the schedule it tells us that the motor shall be 115 volt 60 hertz single phase. So from that we will select, in this case, and I'll slide this over so that we can see this a little better. Voltage is going to be 120, and by the way, 120 and 115 volt is the same thing. Generally it's a range of 10% above or 10% below. So you'll see schedules that have 115 volts on them, or they'll have 120 volts on them. So essentially that's the same voltage requirement for the motor. The motor we'll select as totally enclosed air over motor. Unless we are in a chemical plant or some sewage plant or something that has chemicals, we really don't need an explosion proof motor. Or we can look at the written specifications that came with this particular schedule, and we'll notice here in the written specifications it doesn't say anything about any sort of spark proof or explosion proof motors. It simply tells us about the unit being constructed of steel, that it's sufficiently rigid. It tells us about the materials that it's going to be manufactured of. It tells us about the finish, meaning baked enamel finishes. It also tells us about the louvers, horizontal delivery units. We can have, it requires us to have a horizontal and vertical louver. So we'll see that in the selection tool. It tells us a little bit about the heating coils. And just to note, we should always read the spec. When we're pricing up a job, the schedule is important, but the specification is also important. If we don't read the specification and there are things in there that we need to provide and we don't provide it, guess what? As a representative, as a sales representative, we have to eat that cost. So when you're pricing up a job, it's important to understand it's not only the schedule that matters, but it's the specifications that matter too. So in this case, it tells us about the fan assembly also. So it tells us about the fan. It's a multiple blade propeller fan. That's what we're going to select. And it also tells us about the motor. It's single phase, totally enclosed electric motor. So we're going to go with in this case, we're going to go with totally enclosed air over motor, which is similar to what's specified. Asks us about speed controller. Do we need a speed controller? If it's not written in the spec and it's not on the schedule, then we don't provide it. Because if we provide things that aren't written in the spec or are not shown on the schedule, then we're going to price ourselves out of the job because our competition is not going to provide that unless it's written in the spec and shown on the schedule. Okay. Thermostat. It tells us here that the engineer wants one remote wall mounted low voltage thermostat, and that is going to be per area. So we're going to assume that it's one per unit. So the thermostat says wall mounted on the schedule. That means for us it's field mounted, right? Because we're going to provide the thermostat and the contractor will put it in a location that is that's suitable based on the contract drawings. Aquastat. What's an aquastat? An aquastat is a sensor that gets mounted on the pipe supplying the water to the unit that tells the unit whether that unit's hot or whether there's hot water in the pipe or whether it's cold. In general, unless the engineer specifies that unit or puts in the specifications, we don't provide it because it is an expensive component. Okay. So we'll say no to that aquastat. Some steam applications require an aquastat because with steam piping, the pipe tends to get cold much quicker. Because once the boiler stops delivering steam, the pipe gets cold right away. Okay. So disconnects. We have a variety of different disconnects here. It basically tells us provide each unit with a unit-mounted disconnect switch. When it's just a generic type note that says unit-mounted disconnect switch, then we want to just provide a generic non-fused disconnect, which is the unit I'm pointing at now. If the specification calls for other things associated with the disconnect switch, such as overload and disconnect, overload and pilot light, overload, or manual switches or two-pole disconnects, unless it specifically says that in the spec, then we just want to go with a unit-mounted non-fused disconnect switch. Okay. A motor guard. We should always provide a motor guard on unit heaters because essentially it covers the motor and it prevents anybody from sticking their hands in the fan area and then getting injured from that. So we have an OSHA motor guard on the unit, which we should always have. Okay. Discharge louvers. I mentioned before in the written specification it calls for horizontal and it calls here for horizontal blade and horizontal and vertical louvers. A standard unit that doesn't have this particular field mounted kit will just have horizontal louvers on it. So if the spec calls for adjustability in the horizontal and the vertical, we must provide a field mounted kit in order to add that vertical feature to the unit. Okay, so once all that is done, we've selected our unit, we can hit the performance button and make sure that our performance meets the criteria for the job. Okay, we know we're dealing with water. Okay, in this case, our CFM for this particular unit is 1220. We'll go back to our schedule and see what our desired capacity is. The capacity of the unit that's shown on the schedule is our desired capacity is 52.3. Okay, we know our entering air temperature here is 60 EAT, so we're correct here, entering air temperature. It also tells us our entering water temperature. We know that our entering water temperature temperature from the schedule, EWT, is 180 degrees. So we'll switch that to 180 degrees. Okay, and we know that the delta T on that unit for the water coming in and out of the coil is 20 degrees F. So it corresponds with the difference between 180 and 160, which is 20 degree F. So once we hit the entering criteria, we can hit run performance. And in that run performance, we'll notice there that we get actual capacity of 47.8. That means the unit that we selected was slightly smaller than and produces less capacity than what's required by the spec. So let's close this performance and let's go back to the selection, and let's go to the next size up and see what we can find there. So once we hit that next size, we can go back to the performance module, and then once we open up this window, we can hit, we don't have to change anything here except the CFM, and we can hit run performance there, and we'll notice that the CFM is 970, but we're able to get 52 MBH capacity out of that unit. Now that's one thing that we mentioned before with unit heaters, is that the capacity is what matters. Even though our CFM is lower than the CFM that's shown on the schedule, the engineer will review this and indicate and be fairly satisfied that the capacity matters. With some engineers, they may not. So if we feel that we're uncomfortable with the fact that we're providing a unit that will do less CFM, we can close the performance again and then go back and get our next size up, which is size 84. On the unit schedule, you'll remember the size 84 was indicated there. So let's try the size 84 unit and see where our performance comes out. We don't have to change any of the entering criteria. We'll notice there that it's 1416, it's 1610 CFM. We can reduce that to 1330. All right, and we can hit run performance. So once we hit that run performance, we'll notice that we overshot the actual capacity by about 10 MBH. Our discharge, our water flow is 6.4. On the schedule, the water flow was 6.1. So we're fairly close on that. Our voltage is 120, and in this case, our voltage is 1/6 horsepower, where the engineer called for 1/12 horsepower. Now in general, at fractional horsepowers, the wire sizes are the same, so it does not make a tremendous difference in terms of actual amperage used. However, the engineer may object to that, so we would have to just review that based on a submittal. Okay, so even though we overshot the unit, we can take a look at how the unit performs at 1140. We're down to 57.4 MBH. So we're going to stick with this. All right, we're going to stick with this unit, run at 1140 CFM, and we're going to hit close performance. So we know that our performance is there, and we're able to select that unit heater based on that performance. Okay, so for that, for that particular unit, for those 5 units, we've now priced the job, and we've also done a performance evaluation. Once we've done that, we can use add product in order to save that job. So you'll notice here it says changes saved, and in this particular program, we want to make sure that we don't use this button to go back, but we always use the back button that's shown on the program menu. Okay, so once we hit that back button on the program menu, you'll notice that the equipment comes up with the model number. We have our pricing that's there, and we're using this pricing just as an example, so this is not actual pricing. Okay, you'll notice that all the quantity is there, the performance icon is there, so the program knows that we did a performance, and the item model numbers are here. Okay, from this template, we can also create a proposal by going over to the description shown on the unit. see if we can get there. We'll have to maximize the screen. Description shown on a unit in order for us to take a look at what we're going to use on a proposal. So if we take a look at that again, okay, and we take a look at the description that's provided by the program, we can copy and paste this into our proposal. Okay, so if we have multiple unit heaters, we go through the same process. In this case, we have a single unit. We have 5 unit heaters, all the same size, so we know what we're working with in order to get that pricing up. Okay, so that concludes our module on pricing up a unit heater. We want to be able to make that module, use that as an example when you're doing other jobs. All right, so that's it for now. Look for us on a new module on cabinet unit heaters.